hydrochloric acid plus sodium hydroxide reacting to form water and sodium chloride. One typical example of acid-base reaction. Okay, so here now your work is to convert this into balanced chemical equation. Everyone, please now do it yourself. Don't expect like I will do first and then you copy. Okay, I'm not going to write this equation. This is easy equation. Hydrochloric acid. What's the formula? Prava, can you tell me the molecular formula of hydrochloric acid? Prava, unmute yourself and please tell me the formula of hydrochloric acid.
HCl.
Okay, HCl, that's good. And why your video is off, so it's better to keep your video on. Okay, Mr. Kafle is showing me the answer, but it's horizontal. I mean, make it vertical. Yeah, that's the way. Okay, I think that's correct. Okay, Krishna Kafle, that's fine. Okay, Adib is showing there. Okay, but Adib's handwriting is not that good, like very difficult to see from here. Okay, fine. This is easy one. This is easy one. I guess like everyone can do it easily. Okay, everyone, please try this, and there won't be any problem in balancing also. Balancing also, there won't be any problem. So please, do it yourself. Don't expect me here. And Ayush is looking very happy there. I don't know why. He's saying I'm smiling there.
Me? No, I'm
Yeah.
not smiling, sir.
I can see you from here.
True. Just like this.
Okay, now let me give you next example then. Next example. Let me write here. Okay, now let me write next example. Okay, now let's write sulfuric acid there. Sulfuric acid plus magnesium. Okay, let's write potassium. Potassium hydroxide. Okay. This is next example there. Okay, everyone please try. Okay, try to guess the product also here. Okay, this is now another example of acid-base reaction. Now I'm not writing what products will be formed. Okay, try to guess yourself. Okay, water and salt. Okay, that's what we know. Very easy thing there. But which salt will be formed? Now that you have to find out yourself. Okay, let me put one arrow there. Okay, arrow. So what is next there? What will be the products? Which salt and water? So obviously water will be there, no doubt. Again, along with the water, which salt will be formed? Okay, come on, try yourself. Let me ask Janisa. Janisa, can you tell me? Can you guess which salt will be formed there?
Yes, sir. What
Which
again?
salt will be formed there? Along with water, which salt will be formed? Guess.
No,
Potassium sulfate.
Okay, I don't know who spoke there. Who said that?
I,
I means who?
sir, I was like
Sorry?
disconnected for.
Okay, anyways.
No, me.
Okay, someone said the answer. That's fine. The answer here is potassium sulfate. Now, if you ask me how to find that out, one easy way is. Okay, please listen. One easy way to find that out is, okay, let me explain this in this way. Okay, just you have to look at the base here. Okay, look at this potassium. Okay, you have to look at the basic radical of the base here, which is potassium. Okay, and then you have to look at the acidic radical of this acid. Okay, sulfuric acid is, what's the formula of sulfuric acid? That is H2SO4, right? There is sulfate. Sulfate radical is there. Sulfate radical is acidic radical there, and potassium radical is there, okay, as the basic radical. So from the base there will be basic radical, from the acid there will be acidic radical, and if you combine these two, you will get the salt, which is potassium sulfate. That's the easy way to predict. Okay, that's the easy way to predict. So now here you can write. If you write the formulas, it will be more easy there. Okay, now let me write here. Okay, H2SO4, right? H2SO4 is the formula of sulfuric acid. Sulfuric acid H2SO4. Okay, now look at that. SO4 is actually sulfate. You should know that. Okay, and potassium hydroxide is KOH. Okay, KOH. Now, okay, we have to guess more
H2SO4.
out. Guessing is easy. The
It
H2, this hydrogen part of acid and hydroxide part of base, again, will form water. Okay, H2O will be
H2O.
formed by hydrogen part of acid and hydroxide part of base. Now remaining thing will be formed as the salt, which is your potassium and sulfate. So we can use the different color here. Let's use the
H2SO4.
blue color. Okay.
I think.
So what is left here? Okay, potassium is left, right? You can see potassium is left, and your sulfate is left. Potassium sulfate. Okay. So now the salt here is potassium sulfate, and do not simply write KSO4. Do not simply write KSO4. You have to do crisscross here. Okay, you have to do crisscross. Potassium sulfate.
K2.
For finding out the molecular formula of potassium sulfate, we have to do crisscross, right? Sulfate's valency is 2, and potassium's valency is 1. And if you do crisscross, the formula will be, Karina, what will be the formula of potassium sulfate? Karina, formula of potassium sulfate.
K2SO4.
Exactly. So do not just look at it. There is only single K, right? So looking at this K, if you write KSO4, then that answer would be wrong. Okay, you have to write here K2SO4. K2 K2SO4. So this is the skeletal equation. Now balancing is left, I think, right? Okay, because you can easily see potassium, 1 potassium there, 2 potassium there. So potassium is not balanced, and that means this is unbalanced skeletal equation, right? Unbalanced skeletal equation. Now let's try to balance that. Okay, balancing also won't be much problem here. And for balancing, like one simple trick or tip, whatever you say, is that we always try to balance hydrogen and oxygen at last. Okay, do not try to balance hydrogen and oxygen first. So here, like except hydrogen and oxygen, so what other elements are there? Just look at other elements. Sulfur is there, potassium is there, right? Sulfur, potassium. Other than hydrogen and oxygen, sulfur and potassium there. So now if you look at the sulfur here as one sulfur and one sulfur. Sulfur is already balanced. Now potassium is not balanced here. You can see 1K here and 2K. So that's why you have to use, okay, let's use different color. Let's use this green color. Okay. Now if you put 2 here, okay, 2 KOH. What I'm doing here, 2 KOH. So keeping this 2, now we'll balance the potassium, right? Okay, potassium is balanced, sulfur is balanced. Now what left? Hydrogen and oxygen. So out of hydrogen and oxygen, try to balance any one of them which looks easier. Okay, it's about balance the easier elements first, and leave the difficult ones for last. Okay, you know the reason, because the last element you don't have to balance, it will be balanced itself. Okay, so in this case I think hydrogen will be easy to balance, because oxygen everywhere you can see, everywhere there is oxygen, but hydrogen is not everywhere here. Okay, so here hydrogen is absent, so hydrogen is present here. 2 hydrogen here, you can see there, and this side how many hydrogen? Let's see, 2 plus 2, right? 2 plus 2, 4 hydrogen in the reactant side, and only 2 in the product side. So now the best idea is put 2 this side, right? Okay, 2s2. So now keeping 2 here makes 4 hydrogen this side and 4 hydrogen in the reactant side also. So 4, 4. Now hydrogen is balanced. Now oxygen. Now for oxygen, like let's just count. Like I'm not balancing the oxygen, okay, because this is the last element left. Last element will be balanced itself without doing anything. Look at that. 4 oxygen plus 2. 4 plus 2, 6. And here 4 plus 2, 6. Totally balanced. I didn't balance oxygen. It got balanced itself, right? I just balanced hydrogen. And oxygen was left for the last. And you can see there, oxygen got balanced itself. So that's the way to balance, right? Again, I mean, simple kind of trick here. Always try to balance hydrogen and oxygen at last. Hydrogen and oxygen last. And out of these two also, try to choose the easy one first. We always try to balance from the easier ones, okay? Now that's the second example here. Now let's do one more example there. Okay, let's do one more example. Example number 3. Now, can I rub this all? I hope you have written. Okay, let me rub this all. Let me clear all the drawings there. Now let me write one more example there. Now let's use base one base there, aluminium hydroxide, aluminium hydroxide plus sulfuric acid. Okay. Now come on, guess everything yourself. Guess and then balance yourself. Okay, I'm not going to write here. Now please you write it yourself. Okay, everyone, please try. What salt will be formed? You can guess. Okay, what salt will be formed? You can guess, and then you can balance the equation also. Come on, try.
Ammonium sulfate, I think.
Okay, I have not asked you, so when I don't ask, better not to tell the answer because others are also doing that. Let them try themselves.
Sir, is aluminum sulfate?
Yes, aluminium sulfate will be formed. And don't forget to do crisscross, okay, for aluminium sulfate. Aluminum hydroxide plus sulfuric acid. So now products are water and aluminium sulfate. You can now convert that into balanced chemical equation.
Balance.
Balanced. Okay, so I
Yes.
mean those who have memorized the valencies formulas, those tables, for them these are easy things. Susmita, done? I mean, looks like busy in doing or not busy. Come on, do it. That's good.
Done.
Done. Can you show me?
Sir, done.
Okay, show me. Niranjan, Susmita, show me. Okay, where is Niranjan? I don't see him here now. Okay, where are you, Niranjan? I asked you to show me, and then now I cannot see you at all.
I'm showing.
Really? Okay,
Yeah.
let me stop sharing this, then I can see this everyone's picture clearly. Let me stop sharing this. Okay, now I can see everyone clearly. Okay, where are you, Niranjan? Okay, fine. Wait. Okay, keep showing that. Nanjan, okay,
Done,
keep
sir.
showing. Keep showing. Let me
Done.
keep. Wait. Okay, so this is Niranjan's work, I think. Is it for? Is that 3 or 2? What is that? Okay, so me the reactants also. I cannot see reactants for me. Okay, I think it is balanced. Okay, you can count yourself. Okay, skeletal equation is correct. That much I can say. And I'm not sure about balancing. Okay, you just count yourself. Anjal, have you finished?
Yes, sir.
Okay, you show me then.
Okay, sir. Once.
Come on, you show me your copy. No, you don't need to look there. Just for me, okay? What is the Al2SO4 and after SO4, what is that?
Al2SO4 plus 6S2.
And after SO4, there is nothing. Al2SO4 only.
Sir, 3.
Okay. Then maybe it's fine, I guess. Okay. And you're handwriting this. What is this? It's so rough.
No, sir. This laptop what coming?
No,
So
your handwriting is rough. I mean, don't blame your laptop. Okay, Krishna Kavli is showing me. Okay, let's see here. Okay, aluminum sulfate. Okay, looks like correct. Okay, done. Okay, so I guess I mean most of you have done. So is there anyone who is having problem writing this equation? Is there anyone who is having problem? Like Deepa, have you done? Is there anyone? Okay, please ask me
Yes.
if you are having problem. Yes means you have problem or you have finished. What does that yes mean?
Finished.
Finished. Okay. Show me then.
Roughly.
Show me. What is that? I cannot read it. Okay, now this is better. Al2SO4. Wait. I have not finished reading all. Oh, that's wrong. Al2OH3. I mean, that's aluminum hydroxide formula is wrong. Al2OH3 is wrong. Your first molecular formula is wrong. Now that means everything is wrong. Deepa, you need to do it again. Aluminum hydroxide is AlOH3, right? Aluminum hydroxide, 3 valency of aluminum and 1 valency of hydroxide. 1 valency of hydroxide, don't forget. It can't be Al2OH3. It's AlOH3, right? Okay, so then I mean, like, we should now move ahead there. Because the first factor is heat. Okay, heat is the first factor that affects the chemical reaction. Okay, and generally, what happens? Heat can start the chemical reaction. It can increase the speed of chemical reaction. It can do many things there. Okay, so example, what question mark is that? So in that case also, like, let me write the equation, and you know how I write the equation there. Here, example of heat. Here, it's not example of heat. It's actually example of the chemical reaction affected by heat. Okay, calcium carbonate. Calcium carbonate, if it is heated, you now put the arrow with arrow. Oh, this arrow is like, oh, there's something there inside. What is that? My name? Okay, I mean, with this. I mean, undo. Oh, I mean, this. You don't undo that. Wow. Redo. Calcium carbonate is being heated there, okay? So on top of this arrow, you have to make triangle. Where is triangle there? I don't see triangle here. Rectangle is there, square there, and all other things there. But again, I mean, I'm not getting that triangle, so I'm making this. I mean, like kind of rhombus there. We're gonna make that triangle. Okay, calcium carbonate arrow, and on top of arrow, put that triangle. Triangle means heating, right? Okay. So what do you expect there? Calcium oxide and carbon dioxide. Okay, let's try that. Calcium oxide. And this equation was there in that assignment also, I think. If you remember, calcium oxide plus carbon dioxide. Calcium oxide plus carbon dioxide. Okay, now it's your turn to write this equation into balanced chemical equation. Come on. Write this yourself. Should be easy. So, Isa, what's the formula of calcium oxide?
CaO.
CaO. Okay. So, not a problem, right? So, the heat can cause the chemical reaction to occur. So, this is one of the example of decomposition reaction also, if you remember. The same,
Sir, mine
same
done.
example. Same example was given in that decomposition,
done.
right? So here, good thing is some of the examples will be repeated. So that's easy for us, right? If you get the repeated examples, then I mean we don't have to memorize. I mean different examples for different cases there. So this same example works for here also, works there also. Okay, now second factor. Okay, now let's move on the second factor there. Let me clear up this. Yeah, I'm just dropping this all drawings. I hope you have done.
Yes,
Okay,
sir.
next factor. Next factor. Okay, light. Okay, light also can cause chemical reaction. Okay, so do you remember any example of the reaction that happens due to light? One uh, very easy and like well known familiar reaction is there caused by light. Anyone remembers? Okay, I'm asking everyone. Anyone can speak if you know the answer.
I think it occur in a plant while preparing food.
Yeah, okay. Someone spoke. Yeah, autopilot. Yes, you're right. Talking about photosynthesis, right? Photosynthesis. Okay, the reaction can obviously it is chemical reaction that occurs because of the light. Okay, so can you write the chemical equation for photosynthesis? This thing was taught somewhere in class 8 and 9. The only thing maybe possible is you have forgotten. Otherwise, like you have learned this. During photosynthesis, what substances react to form what substances? What will be the reactants and what will be the products? If you can remember, you can write yourself. Otherwise, let me write here example of the reaction caused by the light. Okay, text box.
Sir, is hydrogen and chlorine.
Hydrogen and chlorine also you can write. But here, first example I'm writing is about this carbon dioxide plus water. Where is arrow? This arrow always comes with my name. Okay, and text box. So what do you get? Glucose, right? Glucose plus oxygen. Okay, so now formulas you can write. Formula glucose plus oxygen. Carbon dioxide CO2, water H2O, glucose C6H12O6. Yeah, if you have forgotten, let me write that for you. Okay, C6 at 12:06. Okay, that's glucose here. Now other things you can write yourself and balance it. The other things you can write it yourself. Okay, try to balance that equation yourself. Okay, Krishna Kafle is showing me, I think, but it not say properly. Yadi, okay, I think that is correct. Okay, Adi. Okay. And those who have finished this equation, they can write Krishna Kafle. I cannot see her properly, really. Difficult to read from here. Adit, can you read Krishna Kafle's answer? If you can read, check that once.
Sir, may also be.
Sorry. Done.
Sir, may also.
Okay. So let me write one more example there. The example that Anjan was talking there about that hydrogen and chlorine. Second example I'm writing there, hydrogen plus chlorine. Hydrogen plus chlorine. Now what you can guess there, hydrogen chloride, right?
HCl, 2HCl, I think.
Yeah, what do you get? So hydrogen chloride. So that's what you get. Hydrogen chloride, where is at? Oh. So write this also, hydrogen plus chlorine, hydrogen chloride. This is one example of combination reaction. Yeah, this example already came there somewhere in that combination reaction, right? Okay, so it should not be that difficult. Carbon dioxide plus water forms glucose plus oxygen. Okay, so if you want me to write it here, I mean, we'll write it, not a problem. I guess CO2, carbon dioxide, H2O, water. One big arrow here, and then oxygen
O2.
O2. So for
H2.
balancing, okay, so for
Alright.
balancing, what you have to look here, let's look at the carbon here. The 6 carbons you can see in this side, and there I can see only 1 carbon. So why not putting 6 there? Okay, now carbon is balanced, 6 carbon this side, 6 carbon that side, right? Now after getting carbon balance, now only thing left is oxygen and hydrogen, right? Now just look at the hydrogen or oxygen, which is easy. I think hydrogen is easier there. Okay, fine, Nadeep. I saw that that second equation also is fine. Okay, now let's try to balance this hydrogen here. There you can see 12 hydrogen, right? And in this side only 2 hydrogens are there. So you have to make that 12. And to make 12, you have to put 6 there, right? 6 to the 12. Okay. 6 to the 12. Okay, so that hydrogen is balanced, right? Now let's see oxygen is balanced or not. 6 to the 12. 12 plus 6. 18 oxygens are there. This side not 18, I think. So 6 and 2. Only 8 are there. That means you have to put 6 here, I guess, right? 6 to the 12. You get 12 plus 6. 18. Right, balance. Hydrogen plus chlorine. Now this would be easy equation, so I'm not going to write this. Again, I'm not going to write that. That's done. Okay, okay. So now I guess everyone has done this. I'm just clearing out this. Okay. And next, electricity. Okay, electricity also can cause chemical reactions to occur. Let's write one easy example there. Easy example. Okay, breaking down of water. Okay, water is electrolyzed. Okay, if water is electrolyzed, it forms hydrogen and oxygen. That's called electrolysis of water. The water giving out hydrogen and oxygen. Hydrogen plus oxygen. Okay. This example there. Water can be electrolyzed. Water can be broken down using electricity to form hydrogen and oxygen. Okay, so try to write this equation yourself. Now I can see, about 1 minute only left. So this is the last thing there. Adib, okay, I
Sir,
guess
done.
that's easy. Okay, fine. Okay, Rip.
Sir, done.
Sir, mine
Okay.
also, sir.
Okay. So if you have done, so the class is over for you. You can leave. And so I hope you have not forgotten what I said. Okay, third episode is for those students who have not understood the previous some topics there. So for them, there will be revision class after this. Don't forget to join. Okay,
Me.
only for them, not for everyone. Okay, so if you have finished up to electricity, yeah, okay, you may leave. Have a nice day ahead. Goodbye. And most probably you will get assignment in Google Classroom.